Today, I'm going to walk through a talk I gave last month now in Austin, Texas for the Day-to-Day Texas 2026. I was honored to be there to deliver this talk, which was the data visualization keynote that I entitled "Who Needs a Chart When You Can Just Chat?" There was a recording done on the day, but I wanted to get this freshly down now that I'm back home. To have it for posterity and for the folks who've asked me for a copy. So yeah, I'm excited to walk through it today. And there may be moments where I refer to the room or out of my practice. Just ignore those bits. Great. So this is Who Needs a Chart When You Can Just Chat? This was a keynote delivered at Day Texas in Austin in January. Very cold Austin. There was an ice storm coming through, which meant it was an interesting time, but it was a really fantastic conference. So thanks everyone for joining me. I have a 2-year-old at home, which means I've been reading a lot of children's books. And one of our favorites is What Do People Do All Day by Richard Scarry. For those of you who aren't familiar, this is a book from the 70s. It's a bunch of anthropomorphized animals going about their daily lives. And it's a fantastic book. It's very dense. It's great to look at with kids. And there's an awful lot to look at in there. Busy Town seems like a pretty cool place to live, although it's clearly not without its dangers. But I've been wondering why, reading through this book so many times, Busy Town seems so particularly like idyllic and aspirational. And I've come to the conclusion it's because everyone in Busy Town has a job. As Richard Scarry says in the book, everyone is a worker. As Farmer Alfalfa there on the left-hand side there, or Stitches the tailor in the middle. Even young Hucklecat has a job as a helper in the family, and everyone has a purpose and responsibility in this world. And at this point, you're probably wondering why I'm talking about a kid's book from the 70s. But don't worry, this talk isn't going to be me, saying what lowly worm taught me about B2B sales. Busy Town has made me reflect on the jobs we do as data professionals, leveraging visualization to help others make their decisions and ultimately do their jobs. Visualization is something you probably use every day without thinking about it. And today I'm looking to change that. So I'm Christian. I flew down from Vancouver Island yesterday. This was back in January. Happy to be here delivering this talk. Thanks to Lynn Bender for the invite. It was really nice to be in the room with everyone and had so many fantastic questions. I'm here with gdotv, and I'll touch upon some of the work we do at gdotv later in the presentation. But my main area of expertise is graph visualization and the network analytics that underpin it. But today I'm taking a bit of a wider look at the role of data visualization, what it does, why it works, and how that's changing. Jobs to be Done is a product marketing framework that was popularized in the early 2000s as a way to explore the way in which products are created and why they are ultimately used. In a nutshell, it helps us to consider the tasks that individuals are trying to complete via your product. And it might sound obvious but fundamental, but we easily lose sight of this when we build products. You might build something to show off, to try out a new technology because you're told to build it by your management, or simply because you can. But none of these are helping your end user to do their jobs. So let me make this a little bit more concrete. You likely work with a number of what I'll call data interfaces when you do your job. These are some of the most common ones I think you'll come across. In the top left, we have dashboards like you might see in Power BI or Tableau. Top right, you have scrolly telling, the sort of visualization you see as part of an article on maybe say the New York Times or other journalistic outputs. Bottom left, these are more subject matter expert configurations for folks to understand exactly their domain, and they're usually very specialized visualizations as part of that view there as well. And then for the data scientists in the bottom right, we have the sort of Jupyter notebook or maybe a Marimo notebook, which help you do your analysis of the data that's there. The job to be done varies between these different interfaces. Dashboards are there to track important metrics over time to keep, say, deployments running, whereas notebooks help data engineers explore data and verify assumptions before production versions ship. But the bottom line is the job of data visualization is to communicate data in a way that enables decisions. Now, data viz is like any visual medium. There are infinite ways to represent data, and therefore there are infinite opinions on how it can be represented. It's funny, if you get it wrong, people will let you know. And if you get it right, people will also let you know how you could have done it differently. And these personal opinions and recommended best practices lead to some pretty strong opinions strongly held. I think some of the more common ones you hear are like, don't use pie charts, don't use 3D charts, always start axes from zero. And I think that these strong opinions really speak to the significance of the data around us and how we talk and how we communicate it.
Now, the talk today is a talk of threes. I will walk through 3 examples of data visualizations that you likely haven't thought about. Along the way, I'll introduce 3 of the most important concepts when thinking about designing and using interfaces. And my goal here is to help you understand why data viz works and hopefully help you sound smart when discussing data interfaces with colleagues. Finally, I'll provide 3 predictions for where data visualizations and data interfaces are going from here. And that'll be the final part of the talk. Now, this as a first visualization here, this is probably familiar to anyone who's used GitHub. It's on the profile homepage, and there's a heat map showing at a glance the commits made over the past year. This can be easily faked. It's just Git commits, and there are tools out there to fake the way that this looks on the profile. And the question is, why would you do that? There's a few reasons. Firstly, you may be looking to impress a prospective employer who's looking at your sort of productivity as a sort of flawed metrics for the past year. Or maybe you just want to put some sort of geek credentials in there, like you want to put like a Pokemon character or something. And it kind of demonstrates to me how seriously folks take this sort of piece of visualization that represents your productivity or your output for the past year. Another example of visualization that you use many times a day without thinking about it is the humble progress bar. And the best example I can think of this is the Domino's pizza tracker. This shows you the progress of the pizza that you ordered. It's pretty novel for 2007, I think it was, when it first was online, when you could first order pizza online. And actually, when searching for images for this presentation, I stumbled on some limited edition themed versions of this pizza tracker. So here you had some ability to choose based on your personal preference, and they even had built-in soundtracks. So I would never imagine that Domino's was like an early pioneer in data interfaces tailored to distinct personas. So the GitHub contribution heat map and the pizza tracker, they're small examples, but they're effective examples of data visualization in action. But how do they work? Let's look at a little bit of theory. When we build visualizations, we're drawing from a set of visual encoding channels, a sort of vocabulary for data visualization. This scan is from a book on the shelf behind me. It's an early formulation of the theory and shows the different channels that you can take advantage of when you're building out visualizations. So, for example, the GitHub graph is using luminance to show the relative productivity for days for the commits. You can see that on the top right of this diagram here. Whereas the progress bar, of course, is length and area. And we also have color or patterns or shapes, or even the 2D location of those points on the chart. This vocabulary works hand in hand with a concept in perception science called pre-attentive processing. It's a sort of simultaneous processing. And the easiest way to think about this is that you see before you think. Rather than comprehending the details of the image, you in fact view it in totality and make judgments before your brain has had a chance to take it in fully. And to me, this is the reason data visualization is such a powerful tool. We're able to leverage such a base instinct to understand what we see before us. And it's important to explore what happens when we don't visualize and rely on other methods of analysis. But before I get to that, let me just explain what you see here. So on the left-hand side there, the channel that has changed is color. So we see one little dot there is red. And if I just showed you this quickly, you would see that red dot very, very quickly. Whereas on the right-hand side, the channel that's changed is shape. You see that if you look closely, there is a circle there in a field of squares. And that actually takes you a little bit longer to work out exactly the pattern in the view there. And we can take advantage of the fact that the color channel is more intuitive and hits that pre-attentive processing much earlier than the shape determination on the right-hand side there when they're all the same color. So again, what happens when we don't visualize and rely on other methods of analysis? Anscombe's quartet is a famous example of a dataset that only reveals its true structure when you visualize it. But I like this more modern take by researchers at Autodesk in 2017. This is taken from Wikipedia. This is the Datasaurus dozen. So it's a really nice animation showing exactly what I mean. So you can see the figures there on the right-hand side. They're changing, but it's beyond the scope of what's being visualized. So the summative statistics don't change for those first significant figures, despite the dramatically different plots that you have on the screen there. And you would have no idea of this unless you plotted the data like this. So that's our first concept, pre-attentive processing. Let's look at an inspiring and impactful example of that in action and another data visualization. These are the warming stripes put together by climatologist Ed Hawkins in 2018. We can see a single bar representing each year with the color representing the average temperature globally. I think this is going back to 1850, I believe it was. There's no labels, no legends, no numbers. It's just a raw depiction, and it catches your eye and makes an impact before you have a chance to fully grasp it. But the funny thing about this visualization, despite it being very impactful, is that according to some thought leaders, it's all wrong. Tufte is a famous figure in data viz, known for his sort of immaculately typeset, self-published tomes on information design and related topics. The probably most popular famous book of his is The Visual Display of Quantitative Information there in the top left. And to give you a flavor of the guy, the story goes that he wasn't happy with with how a publisher was set to typeset his books and arrange the contents, and so he did it himself. And perhaps his most enduring coinage is that of the data ink ratio. In short, this means that every part of a depiction of data should have a purpose. You should be looking to maximize the value of the ink versus the data that's represented. Now, for all the examples I'll show you today, clearly we're talking more about pixels, but the ink is still an important concept when we think about this. He went even further. He said that anything that gets in the way of this ratio is labeled chart junk. To me, and I've seen it mentioned that it's kind of referred to as a little bit of a slur now. People will like throw off the chart junk term to say, this visualization, there's aspects of it that I don't like. And so I think 30 years later, many data viz practitioners get a little bit grumpy at the mention of Tufte's name because his advice and positioning was really influential, but it's all too often treated as dogma. One of my favorite rebuttals or explorations of data ink is Frank Olavsky's take. He's taking data ink ratio to its extreme conclusion. So this is taken from one of his blog posts here. He's a researcher in the space. So here we have a basic bar chart. It's pretty inoffensive, but we have the labels there at the bottom. We have the bars. We have the axis there at the bottom as well. But if you're taking the spirit of the data ink ratio, you could say actually the axis there at the bottom isn't necessary. And why are we using all those colors? That blue color, is that really necessary? So we'll get rid of those, strip those out there, reduce the number of pixels we're using on the screen. And then it turns out, do we need those bars themselves? That's a lot of pixels wasted. Let's get rid of those. And do we need the lines? Are those lines telling us anything about the data itself? If we really want to maximize that ratio, then we don't need those either. And then, there's still a lot of pixels here wasted in terms of communicating this data. Let's just make it as small as possible. Clearly this is preposterous. No one's keen to do this at all, but it shows you that if you take these things to a logical extreme, then it doesn't help anyone. So then going back to the warming stripes, it is a fascinating example where extreme data ink ratio is conveying so much with a single data encoding in terms of that color there. Clearly it could be just a line rather than a bunch of ribbons or a bunch of stripes, but the way that it's designed is very purposeful and it makes a lot of sense. And it shows that data ink ratio is definitely one of those rules that's meant to be broken or adapted to suit a purpose, in my view. So that's the second concept, data ink ratio. For the final concept in data viz, I'll turn to another influential book. In Storytelling with Data, Cole, Nussbaumer, Knaflic makes a distinction between exploratory and explanatory data visualization. Understanding the data is an analyst's job, while explaining the data pivots to being audience-facing, communicating a narrative to others. It's, to me, the difference between running a query and producing a report. I mentioned earlier that I focus on a form of data visualization where we work with networks or graphs. And part of the reason I find this so interesting is I think it exists in the intersection of these two types of data viz. So let me explain. As humans, we are drawn to mapping out complexity. We yearn to understand how things are connected, and graph visualization is uniquely suited to that instinct. Networks are everywhere. Social networks, flight paths, electric grid, database schemas. They're absolutely all surrounding us, and lots of folks will go to great lengths to explain exactly how networks are so important. But with modern web technologies, we can invite individuals to interact with and explore these dense networks, making explanation and exploration pretty much the same act. Now, when we do that sort of interactive exploration of networks, one really popular way of thinking about making sure that's as seamless and as effective for the end user as possible is Schneiderman's mantra. This is overview first, zoom and filter, then details on demand. And it's really the guiding star for every interface that I build and my customers build. So for the overview, we see the whole structure before zooming in. This could be a mini map or a summary bar or something that orients the viewer. Zoom and filter, we're very attuned to this nowadays with Google Maps being around for such a long time. So using the mouse wheel or pinching, but maybe that's also having a legend-based ability to filter the chart or the visualization. And the interactivity here is the point. It's not a feature. It's the whole point of that sort of visualization. And then details on demand, stripping clutter behind hover or tap. This is where chart junk comes back in. We want to avoid having too much on the page to distract from the actual thing that we're looking to convey. So in this case, the information exists, but it surfaces only when it's needed. So let's go to a real example of this. At gdotv, we provide a graph database IDE, and it helps developers query and visualize data for production graph databases. This would include, say, Amazon Neptune, Neo4j, and we support over 30 other graph databases in the space. For an overview, you can query the whole graph and visualize it, pretty much like we're seeing in this view here. But an overview I mentioned a second ago would be like a mini map or a summary bar that gives you an idea of the distribution of that large network before you actually drill into it. Another example, though, could be a schema. Here we have an interactive graphical representation of the structure of the data in the database. And this gives you a different schematic of exactly what you're looking at rather than the raw underlying records shown on the screen. Like pretty much all graph visualizations, you can zoom in and explore. This is just a screenshot, of course, but I can filter with the legend on the left-hand side, which is another common pattern where we're generating those legends so we can turn them off on demand and focus on the things that we care about. And then back to detail on demand as part of the mantra. Harkening back to Tufty, we want to minimize the clutter and that chart junk and choose not to include all attributes in the visualization. And so in gdotv, you can select a node and see the context when needed. So that was the third and final data viz concept I wanted to introduce you to today. We are about 15 minutes through the presentation, and I haven't mentioned two little letters even once. I've seen a few other talks today, and pretty much everyone's talking about this. Those two letters, of course, AI. AI cuts through everything. It's creation, consumption, the volume, the medium, the tooling. Pretty much everything is touched by AI and is changing the way we think about doing things. It, of course, impacts data visualization, and I want to explore that for the remainder of the talk today. As I mentioned, the use of AI is, of course, a hot topic, and I want to strip back some of the hype and reassess the transformational nature of the technology. And one way that I like to explore this is looking back in 2014, this XKCD comic, some of you may be familiar with it. And it basically says that some things in computer science are hard, some things are easy, and it's not always clear which are which. 11 years later, and the example given here is no longer correct. With vision models, we can trivially find out whether an image is a photo of a bird or not. And in the world of data visualization, due to a strong understanding of visual encodings and core technologies that are used in the space, LLMs and related tools do a fantastic job creating charts and graphs from data sets and natural language descriptions. And what about the data interfaces we've touched upon so far today? AI collapses the distinction between exploration and explanation. You get an answer to the question it guessed you were asking before you realized it, which has a risk of actually being the wrong question. The exploration used to require friction and skill, but LLMs remove the friction and give the impression of skill. The first pass I saw for many data interfaces was the addition of a sort of chatbot on the right-hand side, the sort of bot that you'd see on websites when buying plane tickets or tracking a parcel. Documentation and internal information was already available for these, and I think it was the sort of low-hanging fruit for folks embedding AI into the applications. I describe these pejorative as chatbots, which is a bit of a broad term, and I know it has a much wider use. But to me, that word kind of represents the frustrating experience pre-LLM of trying to do a job on Rails. They're very verbose, often hitting you with a wall of text, as you can see there in this mock-up here, and often explaining that they can't actually help you. You're asking for something that they're not able to do, but maybe they don't even, of course, they don't understand this, but they also are giving the impression that they don't understand what you're asking them for. And I don't know about you, but these chatbots on the side of these applications give me severe clippy energy. The approach to adding AI to interfaces definitely has got a bit better. So there'd be multimodality to the outputs and blending widgets from the main interface into the sidebar. And this allows the main UI to be driven by the natural language interface on the right-hand side. I think the biggest challenge here is discoverability. How do you know what this tool can do for you? It's hard to portray that in the sidebar there. A typical form would be like, try asking me these questions, but still it's not a comprehensive understanding of what that bot can be doing for you. And then the other challenges, of course, are hallucination. It could be telling you something that it actually can't do or some information that it actually doesn't have. It's clear to me that these sidebars are a bit of a dead end when it comes to the development of data interfaces. And a combination of the proliferation of these AI tools and their capabilities is leading practitioners to create fresh interfaces to help users do their actual jobs. I liken this approach to those paths you see where people have worn through grass instead of, treading on a paved sidewalk. They're known as desire paths, which is a really nice term. I think about these a lot. Instead of being constrained by the interface that we've built and added to over time, AI tooling helps us prototype and experiment with fresh applications, micro tools, or artifacts that help us get to decisions faster. And I'm coining a new term for this approach when building visualization, the idea of a minimal viable visualization. This is just enough of an interface to get the job done. And just enough doesn't mean that these apps or interfaces are underwhelming. They're often fully featured, the sort of thing that would have taken days or weeks before to build out. They have interactivity at their core. They have toggles and sliders to explore, hypothesize, assess data. And they're micro tools typically for a single job. And then sometimes you just throw them away. Data visualization researcher and educator Enrico Bertini uses the word supple to describe the use of AI to make these tools. And I think that's really nice. It's the ability to create artifacts through natural language still, to me, feels like magic. We haven't yet seen vendors bake MVV, as I'll call it, minimal viable visualizations, into their user experiences, but it's definitely coming. Platforms for malleable data decision interfaces that can be remixed on demand. I think there's a massive need for this going forwards. We're closing the door on clippy chatbots and threading AI into data interfaces that adapt to what we need when we ask them to. Now, I mentioned earlier that BusyTown is an example of anthropomorphization. It's not what do animals do all day, it's people. For kids' books, this is common and generally accepted. But for LLMs, we're told not to anthropomorphize them, the argument being that they are not people and they don't think. Treating them as if they do think grants them agency where none exists. It's cognitively dissonant. Language models are constrained by language. Juan earlier quoted Wittgenstein saying, "The limits of my language are the limits of my world." And this holds true for LLMs. The way that they are able to reason, code, is an emergent behavior. We're told they're probabilistic engines simply predicting the next token, but emergent means that we don't truly understand how they work. And visualization researchers are turning to visual methods to derive interpretability. Apple open sourced their embedding atlas last year. It's a visual way of exploring high-dimensional vectors that encode semantic relationships. We can see how concepts cluster, spot outliers, and understand what the model treats as similar. And this is part of a domain that's called mechanistic interpretability, which is another great phrase you can use to sound smart. Anthropic, creators of Claude, shared a tool called Neuronpedia, which reflects on the parallels between biology and neuroscience and sees what that tells us about LLMs and how they think and reason. And as part of this research, and by leveraging these sorts of minimal viable visualizations, researchers asked Claude to generate a poem and observe the internal features that activated when that poem was being generated. And they actually discovered that instead of simple token prediction, Claude planned ahead to ensure that the poem rhymed. The network visualization shown here allowed them to discover this. Now, one thing you may wonder is if these charts are so important, can't we just feed those back into the visual models to get them to do this work and come up with these sorts of findings for research? Well, recent papers show that these models don't perceive visually the same way humans do. If you remember pre-attentive processing, seeing before you think, these models don't do any of that. They perceive global properties better than local ones. They'll tell you a graph is densely connected, but miss that two specific nodes are linked. And this is the opposite of what you'd expect if they were actually seeing the graph. And so this interpretability research, combined with a lack of friction to create minimal viable visualization, leads me to my next prediction. Network graphs and the data interfaces that help us explore and explain them will become standard, not a specialist tool. We'll see them as important for interpretability, and we recognize their inherent power for working with a new paradigm of collapsed exploration and explanation. Schneiderman's mantras and other best practices still hold, powerful and relevant for building UIs today and tomorrow. Another data visualization that's exceedingly easy to create with AI are infographics. I fed all my notes, all my slides, some transcripts from some recordings of some rehearsals for this talk into Gemini, or Nano Banana Pro is the name of the model, and created this visualization as a sort of infographic of what I've been talking about today. And on first glance, it looks good. And again, if you told me 10 years ago that this was possible, I probably wouldn't have believed you. It seems in some ways quite magic. But on closer inspection, it definitely falls down. It's a bit muddled in some terms of some of the logic there. I know the text rendering is getting better, but it's any typography nerd will look at this and say it's pretty atrocious, and there are some garbled words there in the top right. And I'd say there's no taste. There's no taste for this visualization. It's just sort of a grab bag of things that it thinks it should have included. And again, I'm automatically anthropomorphizing it and saying it thinks it doesn't think. It's just spewing it onto the page. Um, and do LLMs of today have the same restraint as Ed Hawkins with his warming stripes? And if we think back to Tufte's painstaking manual typesetting of his book, this depiction of information is kind of the polar opposite in many ways. If chart junk is the stuff on visualization that gets in the way of the message, are automatically generated images like that one a new form of junk, chart slop? My final prediction is that human authored, or at least human vetted, will become a marker of quality or distinction in visualization. You could argue that human input doesn't directly correlate to quality, but the human touch provides an intentionality that is so lacking when individuals blindly defer chart building to AI. There'll be an emergence of maximalist approaches to data visualization, a kind of artifact of the drive to build something novel and innovative to separate ourselves from the chart slop. And my last example from today is a particularly innovative example of human created visualization. Gabriel Marite at the team at Figures and Figures created these visualizations. They're for a piece in Vox explaining the transition to clean energy. Their encodings were really intentional. They avoided apocalyptic color palettes of smokestacks and melting ice caps. They used real American landscapes there, purposeful typography, and there's a hidden irony in the choices that they've made there. I mentioned at the start the visualization invites strong opinions, and you get it wrong, people let you know. Get it right, they'll still complain. The response to these pieces was exactly that. One hilarious response I saw was Vox invented a new type of chart crime, while others called it deranged. But many praise them as bold and distinctive, and personally, I'm a big fan. Not all visualizations need to look like this, but the point is to provoke a reaction, communicate a message, and stand out from that chart slop. So there we have it. 3 examples, 3 concepts, and 3 predictions for where we go next. The 3 concepts I shared today, pre-attentive, processing, data-ink ratio, overview first, remain valuable in the face of AI. And that brings us all the way back to BusyTown. I started this talk reflecting on the people of BusyTown and the jobs they do. AI is absorbing tasks, collapsing friction, generating charts faster than we ever could. But the job was never to make the charts. The job was to communicate important concepts to others and to make something AI cannot make alone. And that's your job. Thanks again for your time. Some contact details here. Happy to take questions.